Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called The Long and Short of It by Not Very Neat. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. We have red band lines, where pink lines must contain a set of consecutive, non-repeating digits in any order. So, for example, you could have something like, say, 2, 4, and 3 here, and that would be valid because these digits must form a set of consecutive, non-repeating digits. What you could not have, though, is something like 2, 2, 3 there, because we have a repeating digit there. And you could not also have 2, 5, 3, or something like that, because 2, 3, and 5 are not a set of consecutive digits. And those are examples of how Renban work. We have Kropke dots, where digits separated by a white dot are consecutive, and digits separated by a black dot are in a 1-to-2 ratio. And not all dots are necessarily given. So, for example, if this were a 2 here, this would have to be 1 or 4 to maintain the 1-to-2 ratio between them, because there's a black dot between them. If this were, say, 6 here, this would have to be 5 or 7, because these digits have to be consecutive because there's a white dot between them. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, these two digits are in a 1-to-2 ratio, and they form a consecutive set of digits with this third digit. So it could be 1, 2, 3, 2, 3, 4, 3, 4, 5, 4, 5, 6, 5, 6, 7, 6, 7, 8, and 7, 8, 9. But the only ones of those that contain two digits which are in a 1-to-2 ratio are 1, 2, and 3, and 2, 4, and 3. So we're guaranteed we need a 2 and a 3 here. And the other one can be 1 or 4. So if we have 1, 2 here, this would have to be 3. If this is 2, 4 here, this would also still have to be 3. So either way, this is guaranteed to be 3. And we have a guaranteed 2 here with 1 or 4 to be a run band. Okay. Therefore, this digit cannot be, it's in a 1-to-2 ratio with another digit. So the digits which can't be in a 1-to-2 ratio, or can't be next to a black Kropke dot, are the digits which can't be in a 1-to-2 ratio with another digit. And those are 5, 7, and 9. If you have all of them, you get 2.5, 3.5, 4.5. If you double all of them, you get 10, 14, or 18, none of which are digits. So this can't be 2 or 3. It could be 1, 4, 6, or 8 here. If this is 1, it has to be 2 here. If this is 4 here, this has to be 2 or 8. If this is 6, that's 3 here. If this is 8, this has to be 4 here. Okay. Oh, these two digits are in a 1-to-2 ratio, and they form a set of consecutive digits. So this is 1, 2 as a pair. That eliminates 1 and 2 in the rest of the row, so this can't be 1 or 2. It's 4 and 2 to make that a red band. This then cannot be 4 here, cannot be 2 here because of 2 in the row. So this can't be 1 here. So this is 6 or 8, which is in a 1-to-2 ratio with 3 or 4 respectively. Okay. This cannot be 4 and 8. If this is 4 and 8, how do you form a 4-length Renban with that? You can't, right? 4 and 8, 4 can be with 5, 6, and 7 to form a 4-length Renban. 8 can be with 7, 6, and 5 to form a 4-length Renban. But once you add the 8 and 4, they're no longer going to be consecutive. So this has to be 3 and 6 here, which must have 4 and 5 on it. 4 can't be here because of 4 in the box. So that's 5, and that's 4 there. Therefore, these two digits must be in a 1 to 2 ratio. They cannot contain 2, so no 1, 2, no 2, 4. And they can't have 3 and 6, so therefore this is a 4, 8 pair. Which, again, to form a run band, a 5-length run band does work, but we have to have 5, 6, and 7 with them. So 5 can't be here because of 5 in the row, so this is 6 or 7, which means this must be 5 here in one of these two cells. So 6 is, if this were 6, it would be only consecutive with 5 or 7, but this 5, 6, 7 triplet eliminates that possibility here. So this has to be then not 6, it's 5 and 7 with 4, 8 here, because 6 can't be here, because if 6 were here, then that, well, it's not possible because of the 5, 6, 7 triplet in the column. Okay. So this is 4 or 8 here. It cannot be 4 and 5 because the 5 is guaranteed to be one of these digits. So it could be 4, 3, and 2 if this were 4. If this is 8, it would have to be 8 and 7, but the problem is 8 can only form a 3-length ram band with a 7 involved. So then this cannot be 8. It must be 4. This is 5. That means this can't be 5 there. Because, again, 8 would have to be a 3-length ram band with 7, 8, 9, or 6, 7, 8. But the 8 has to be consecutive with the 7 there, and that's not allowed. So this must be 4, 3, and 2. 1 cannot be consecutive, can only be consecutive with 2, so this can't be 1 here. 6 would have to be only consecutive with 7, so 6 can't be here. So this can only be 7 or 8 or 9 here to be consecutive. 1 cannot be here, 6 cannot be here because 6 would require 7 to be here, and that would eliminate all possibilities for that cell. So this must be then 7, 8, or 8, 9, which guarantees an 8 is there. So this can't be 8, that's 4, which makes that an 8. Remaining digits in this left-hand central box must be 1, 6, 7, or 9. And the 1 has to be, and this 2, 3 pair eliminates 2 in the rest of the column, so that's 1 and 2. 1 eliminates 1 here. So where is the 1 in this box? If this left central box, it must be there. Okay, these are 1 and 2 pairs without a 4, so it can only be 1 and 2 and 3 and 6. Well, 6 can't be here, so this must be the 3, 6 pair. That leaves this as 1 and 2. Remaining digits in this box then have to be 5, 7, 8, and 9. And these must be consecutive with 3 or 6. Well, it has to be 5 and 7 here to be consecutive with 6. 3 requires a 4, or it requires 1 and 2 to be consecutive with it. So therefore, this is 6 with 5 and 7. Actually, it doesn't have to be. It could be 7 and 8 or 5 and 7 here. That makes this 3. Either way, we can guarantee a 7 here. That means 7 cannot be either of these. So one of these is guaranteed to be a 9, because 9 cannot be consecutive with a 3-length ram band with 6. That means this can't be 9. This is 6, 7 as a pair, which eliminates 6, 7 in the rest of the box. So this is 8 and 9 as a pair there. Okay. These digits are in a 1 to 2 ratio. We can't have 1, 4, or 8 here. So this could be 2, 3, or 6 here. If we have 2 here, this is 1 or 4 here. If this is 3, that's 6. If this is 6, that's 3. Okay. So 2 would have to have a 3 with it. And it could be 1 or 4 with that. So if this is 2, we have to have 3 and then 1 or 4 there. Because 3 can't be here because of 3 in the row. If this is 3, it could be 4, 5, or 2, 1, or 2, 4, or 1, 3. It's kind of broad. What are the remaining digits? Where are 2 and 3 in row 4? Can't be here, can't be here. So 2 and 3 have to be here in row 4. That leaves also 5 and 8 as possibilities. So this cannot be 3. So that means this can't be 2 here. So no 3. So this must be a 3-6 pair here. So if this is 3, it can't be with 2 here. So if this is 3, this has to be 4 and 5. So this would be 4, and that would be 5 in that instance. 6 could be with 5 and 4. 6 could also be with 5 and 7. 6 can also be with 7 and 8. We don't know. So those are, sorry, cannot be 8 here. So 3 has to be with 4 and 5 because 2 can't be here. Because of 2 has to be one of these 3 digits here. There's no 3 here because of 3 in the column. 6 can be with 4 and 5 here. Cannot be 6, 7, 8 because of 8 in the column already there. So it's either 6, 4, 5, 6, 5, 7 here. Either way, 5 is guaranteed to be here. So this is 5, which eliminates 5 in the rest of the box. So this is 2, 3, 8 as a triplet, which eliminates 8 in the rest of the row. So this is a 5, 9 pair, which eliminates 5 and 9 in the rest of the box. So this can't be 5. It's a 7, 8 pair there. These are consecutive, and they cannot have 3 or 6. This can't be 1 or 2 here because of 1, 2 in the column. So this is either 4, 5, 7, 8, and 9 there. These are consecutive. Without, this cannot be 1 here. 4 would be consecutive with 3 or 5. But it can't be 3 here because of a 3, 6 pair, so that would be 5. If this is 5, it's not consecutive with 6 because it's the 3, 6 pair there, so this would be 4. But these also must form a set of 3 digits here. So if this were 4, you would have to guarantee 5 there. So this could not be 4, 5. It'd have to be 4, 3, and 2 here, but we can't have 2 and 3 because of 2 or 3 in the box. Let's do remaining digits. So we have 1, 4, 6, 7, and 9. 6 cannot be either of these. 4 cannot be either of these. 1 cannot be here. If 1 were here, that would have to be consecutive with 2 and 3 on the Renban. So these cannot be 1. We have 7 and 9 here. That's not going to be consecutive with 4. So this can't be 4. This can't be 4. So this must be either 6, 7, and 5 and 8, or 7, 9, and 8 here. So this is 5 or 8. We have to have a 7 in this one of these two cells. That eliminates 7 in the rest of the box, so this can't be 7. That's 4. So we have 4, 5 with 3 or 6. No 4, 7 here. No 7 here. 3 eliminates 3 here, so that's 2 and 3. 2 eliminates 2 here, so it's 1 and 2. That means this can't be 1 anymore. Where is 1 in row 5 or row 6? It must be here. 7's one of these two. If this is 7, 9, and that's 8, 8 would have to force a 7 or 9 here. And that would not be possible because of the 7, 9 pair in the column. So this cannot be 7, 9. So this must be 6 and 7 here. So we have 6 here, 7 here. That makes this 9, which makes this 8, which makes that 9. 7 eliminates 7 here. So that's 8 and 7 there. So 5 would force 4 to be there. 8 would force 9 to be there. So this is 4 or 9. Okay. Where is 1 in This upper right-hand box cannot be here because of 1's in the column and row. So 1 has to be there. That leaves 7, 8, and 9 remaining in the rest of that box. Okay. Remaining digits of row 2, we have 5, 7, 9. And this cannot be 5 or 7 because of the 5, 6, 7 triplet here. So this must be 9 here, no 9 here, no 9 there. Okay, where's 8 in this upper left-hand box? Can't be here because of 8 in the column. Can't be here because of the Renban. We already have an 8. Can't be here because of 8 in the row. So 8 has to be there. Where is 3 then in this upper left-hand box? Can't be either of these because of 3. Can't be on the Renban. Can't be 3 here because of 3 in the row. So 3 has to be one of these two digits, which means this can't be 3. That's 6, which makes this not 6. That's 3. 3 eliminates 3 in the column, so that's 2, which makes this 8, which makes that 3. Remaining digits in this upper right-hand box are 3, 5, 6, 7, but this can't be 6 because of 6 in the column, so this is a 3, 5, 7 triplet, which eliminates in this upper left-hand box, which eliminates 3, 5, 7 in the rest of the box. This can't be 7, that's 6, this can't be 6, that's 7, which makes that a 6 there. Okay. No 3 or 5 here because of 3 or 5 in the row, so this is 7, which makes this 5, which makes that 3. 5 eliminates 5 here, so that's 7. 7 and 8 eliminates 7 and 8 here, so that's 9. This can't be 9, so that's 5, which makes that 9. None of these are 9 here. 5 eliminates 5 here, so that's 8. 8 is only consecutive with 9 out of 4 and 9. So 8 eliminates 8 here, so it's 7 and 8 there. Remaining digits of row 1, we have 5, 6, and 9. This can't be 6 or 9 because of 6 or 9 in the column, so that's 5. This can't be 5 or 9 here, so that's 6, which makes that 9. Remaining digits of row 3, we have 1, 2, and 4. This can't be 2 or 4 because of 2 or 4 in the column, so that's 1. That leaves this as a 2, 4 pair here. Remaining digits of column 3 are 2 and 5. Remaining digits of column 4 are 6 and 7. Remaining digits of column 6 are 1, 2, and 4. This has to form a 3-length Renban. 1 and 2 don't form a 3-length Renban with 6 or 7. This has to be then 4, which makes this 2, which makes that 4, and that makes this 1. 4 and 6 and 5 form a 3-length Renban. So 6 eliminates 6 here, so it's 7. 5 eliminates 5 here, so it's 2 and 5. That leaves remaining digits in column 5 as 2 and 8. This can't be 8 because of 8 in the row, so that's 2 and 8 there. Remaining digits of column 7 are 3 and 4. This can't be 4 because of 4 in the row, so that's 3, that's 4. Remaining digits of column 1. We have 4, 7, 9. No 4 in either of these spots because of 4 in the rows, so 4 is there. This is 7, 9 as a pair. Remaining digits of column 2. We have 1, 3, and 8. 3 and 8 cannot be here, so that's 1. 3 can't be here, so that's 8, which makes that 3. Remaining digits of column 8, we have 2, 7, and 9. 2 and 7 to 9 cannot be here, so that's 7. 7 and 2 can't be here, so that's 9, which makes that 2. 9 eliminates 9 here, so it's 7 and 9. That leaves this digit as 5, this digit as 1, and this digit as a 6. And that's a solution. Fairly straightforward. I wish I did it in the actual order where you should probably be doing it, which is this way, then going for each of the black crop key dots. But yeah, sometimes you do it in a different order than is probably the preferred method, a preferred route. Excuse me. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.